In this tutorial we are going to learn how we can use the PCA9685 16-channel 12-bit pulse width modulation servo controller. I'm going to control 16 servo individually. I'm going to show you how to control individually few of them, and then I'm going to show you how to control all 16 of them with the same or different angle. You can get the code for this by clicking at the link below the video in the description, which will take you to robojax.com/learn/Arduino. Let's get started with this. I will reply to all comments and questions of my channel subscriber. Make sure to subscribe and leave the notification on. And this is the module. We have 16 ports here. These 3 pins belong to one servo. This belongs to other servo, where we can connect this servo motor with 3 wires in here. As you can see there, even the color matches. The darker color is the ground. All of these are ground, which are connected to this ground and to this ground pin. And the middle pin is for the power of servo, which will be connected to this middle. And that is 5 volts. All of these are connected to this pin. So you can connect external power of 5 volts to this and this pin. The reason to connect external power and not Arduino is that you cannot power up all the servo motors. Maybe one servo, small servo, is possible to be powered, but for proper practice you should always connect external power. So you will have external power, and for this chip to operate we will connect separate voltage to this VCC. Then this V plus is the same pin as this, so they are connected. So if for some reason you cannot connect here, you can connect your external power here. On this side we have ground, so this ground and this ground is the same, they are connected. And then we have OE, this is a pin. That OL, you can leave it, but for better practice connect it to ground or 0. And these are the 2 pin, SCL, that the clock pin, and SDA, the data pin. SDA and SCL are used for I2C communication to control. Instead of multiple wire, we just use 2 wires to control 16 servo. Here we have terminals, and in case if we want to cascade and connect 2 or more on this side, we can control up to 64 servo motors connected, cascading here. So all of the servos will be connected on these ports. The length of this module is 62.1 millimeters or 2.44 inches. The width is 0.99 inch or 1 inch or 25.2 millimeters. The depth is determined by this capacitor, which is the biggest component here, 14.1 millimeters or 0.55 inch. And if you're concerned with weight, it weighs 10.6 grams. And briefly to explain, this is micro servo, small one is G90, and this is the metal version of this, a little expensive. And this is a high torque servo with metal gear. In both cases these can rotate up to 180 degrees. If you pay attention here, it can go only half of a cycle, half of a circle. So this is 180 degrees, and this also can go 180 degrees, and it will stop. We will use this module to control these using pulse width modulation signal to control them between 0 and 180 degrees with different pulse width. And here is the datasheet for PCA9685. This is from NXP Semiconductor. Originally it has been designed to control LED using pulse width modulation. With pulse width modulation, so we can use so we can control servos as well. I will provide you the link in case if you need further information. And the operating voltage is 2.3 to 5.5 volts, and because we are using servo motors, we will connect it to 5 volts, and it can tolerate up to 5.5 volts. The chip is offered in 2 package type. Here TSSO P28 and also HVQFN28 with square shape. Here is the schematic diagram. This is from Adafruit, with the exception of this section where we have a MOSFET that is for reverse voltage protection. This does not exist in the module that we have. Everything else is exactly the same on our module. This is a chip. We have 4 ports of 4 connectors which are connected to 16 servo motors. We have signal, 5 volts and ground. The 5 volts is connected to the main terminal that we have. And here are the pins where you can solder and select different I2C address and can control multiple of these modules. And here are the inputs, including SDA, SCL, and an LED with a 470 ohm resistor. Let me explain the wiring. The first thing that we do is we connect external power source of 5 volts to this, because all the servo motors, majority of them are 5 volts. So you will connect your servo motor here and the power will go directly to the servo. Now when you connect the power here on this module, this chip will not receive power, because this VCC on this side and ground on this side, this VCC is directly connected to the middle pin, not to this chip. But it is connected to this pin, which also you can connect your positive here if you wish, but I'm going to show you how we can use that. So these two is connected to my battery, and you will connect your servo motor at these terminals. As you can see, the color matches here. The darker color will be on this side, the red is at the middle, and then orange is on this side. If the wire is white, the white will be on this side, which is the signal. So you will connect your first servo like this, and then connect the second, third, fourth, and so forth up to 16. And by number, this is servo 0, this is 3, and the last one is 15. Some of the servo wires you might see might be like this. In this case, the black is the ground, this is VCC or 5 volts, and white is the signal. Ground is connected to the ground, this purple pin, and then blue is connected to the ground using this blue, because manufacturer is suggesting that not used, connected to the ground. Then here we have SCL and SDA. SDA is yellow, it is connected to A5, and SCL is connected to green using A5. So these are I2C communication pins. You can also connect it to SDA and SCL in here directly. The last pin here is orange. Orange is VCC, which supplies 5 volts. I've connected here to 5 volts, this orange. So this will get 5 volts. Now if you want to use external power, then disconnect this 5 volts here and connect this from here to this pin. So we are supplying 5 volts from this, sending back to this chip. And then we can also supply 5 volts from here to Arduino. Once we remove this orange pin, now this is useless. I'm just disconnecting it from 5 volts. And I have to supply 5 volts to this pin. This will work. Actually, you can connect it to VN here. But because we are connecting 5 volts in both cases, this is better, because this VN goes through the regulator and will reduce it. But if you connect it directly here, this will go to the 5 volts of the board, and then you can connect it to your battery like this. So at this point we have 5 volts to Arduino when there is no USB, and then 5 volts is also connected to the module. Let me explain the basic code. I've taken the library from Adafruit from GitHub, and the link will be provided, included with this, and I've made some modification. You'll need to install the library. The first line, wire.h, that is required for I2C communication, which is used with this board. And then this line include Adafruit pulse width modulation servo driver.h, that is their library. we have to, this line means grab that library and use it. Once I will give you a zip file that you click and download and save it in your computer, let's say my document or download. After that, click on sketch, include library, add .zip library, and then point it to where you have saved it. For example, if this was inside the download, go to download and select the file, the zip file, the library, and click open. After that, you have to make sure to close all the instances of this library, otherwise you will not be able to see it in the example. From this class, we are creating here the instance of the class. We call it PWM, or pulse width modulation, and this is the main class that is being initialized. Servo minimum, servo maximum are the values that I've determined with experiment. I have separate video explaining that. I will provide you the link, watch that. Inside the setup, we initialize the serial monitor to print some information for us, and here if I open it, the program is already running. So then we use pulse width modulation.begin. This is starting the library and settings, and pulse width modulation set pulse width modulation frequency 60. This is a 60 Hertz or 60 times the update frequency. And here inside the loop, this is a code where it runs continuously, and I have two for loop. One for loop goes from 0 to 15. This means less than 16, which means 15, and it starts from here. And here you see this square, it shows the closing of this. So it goes I equals 0, 1, 2, 3 up to 15, and then I have another for loop which starts from here and closes here. The job of this one is to start from 0 to 180 degrees. You see it's 181, and every time it goes from 0 and then it becomes 10. This plus 10 means add 10 to the previous value of angle, which was, for example, if it starts with 0, it will be 10, and then 20, 30, 40, and so forth up to 180. So, and then we wait 50 milliseconds, give it a little time so the servo can move. So how it moves is that we say pulse width modulation set PWM I. This I is 0, 1, 2. This is the number of our servo, and leave this at 0, and here angles to pulse and then angle. So if we put the angle, that's our value, but this module needs pulse. So this is a function that I've written that takes the angle, that angle which is 0, 10, 20, 40 up to 180, and returns a pulse, which I will explain next at the bottom. So this receives a pulse for this servo, and that servo, if it is 1, servo 1 will move to that angle, and then it becomes 2, 3, it goes to servo 2, servo 3, servo 4, and so forth. So servo 1, and then I will become 2, it goes to servo 2, servo 3, up to 100, up to 16 servo, and after that we wait 1 second, and the loop will continue from servo 0 up to servo 15. Here is the angle to pulse. The value that you pass here will receive that angle from 0 to 180. We will receive it and we have to map it, meaning the angle that you receive is from 0 to 180, and we have to put maximum and maximum of the servo. So when it is 0, it goes to the minimum, which is 121. We have defined it here through experiment, 125, and for maximum is 575. So this max, so the job of this map is to convert that value to the minimum and maximum, and the result will be here as a pulse integer, and this is just printing the text on the screen for us, and then the pulse will be returned here. It says return pulse. So every time you call this line will get a pulse value, like between 125 to 575, some number according to the angle, and it will move the servo to that location, to that angle. Now let me demonstrate it. I've connected all the servos, and this is now connected to Arduino. The main power is not connected to this module. This is 5 volts, and I'm connecting it now. As you can see, each servo 13, 14, 15 will run. There is 1 second delay, and then servo number 0, 1, 2 up to 15 will run. This is the basic code that shows you how each servo can be controlled at any angle. And if you want to change and control different servo, you can use this line. Just put here your servo, for example 5, servo 5 or 6. This 6 means servo number 7 will be controlled, and here put your angle. If you want it to, for example, go to 130 degrees, just type here 130 and it will convert it to pulse, because here we need to type the pulse, so this function will take care of that. So use this line to control it, each servo at any angle. Right now it's running, the code is running and sending signal because there is no power, so you don't see the action of servos. When I turn it on, it just continues from wherever it is. This is the code where only servo 5, 8 and 15 is being controlled to go at different angles. So the angles go from 0 to 180. So these 3 will move. The rest of the code is exactly the same, and I did not put I put 5, 8 and 15. It's just random for demonstration. The point is that you can use this line for your own purpose. Discard these for loop, because if you want to control only one servo or 2 or 3, just make multiple copy and change this accordingly, and the angle that you want, just put it here. And here is a demonstration for that. I am powering it up. As you can see, 5, 8 and 15 is only working. The rest are off, and they are working simultaneously. And if I open the serial monitor, and here the serial monitor shows that what angle is corresponding to what pulse value. And this is the code where the for loop goes from 0 to 180, and inside loop goes from 0 to 16, and I is changing with the angle, so it controls all of the servos together. So this loop goes with let's say 0 degree, and it goes to all servos immediately without a delay. I did not put any delay, so it goes 0, 1, 2, 3 up to 15. All of them will move to the same location, and immediately it goes, the angle changes, they go to the next one, let's say 10, and then they go to 20, 30, 40 up to 180, and the loop waits for 1 second and comes back and does the same thing. And here is a demonstration. I'm uploading the code. Right now Arduino is plugged in. I can unplug the Arduino. You see it's not working, but if I power it up and power it up using external power, now it's running with the external power without Arduino connected to USB. Thank you for watching. This was how to control 16-channel servo motors using Arduino. If you learned something and found this useful, please thumb up, as this will help my video in the search algorithm of YouTube. If you have comment or question, make sure to subscribe, as I will respond only to subscribers.